Alright, ladies and gentlemen, hopefully this will be a little bit better today. We are going to talk about our trigonometry, and we're going to talk about the formulas that we're going to need to use, which I believe are on the formula chart. Let me double check that. Yes, they're on the formula chart. If you look underneath your geometry and trigonometry section, where it has your right triangles, then it has all that information listed. So we have our hypotenuse, our side opposite, and our side adjacent. All of those are always decided on the reference angle. So since I have my angle marked down here on the bottom, then the side that is straight across from it is known as my opposite. And then the side that's right next to it is known as my adjacent. And then the longest side is always your hypotenuse. And your hypotenuse will always be directly across from your right angle. Your right angle won't ever be your reference angle. So that is one thing to remember. If I put the angle here, then this would have been my opposite, this would have been my adjacent, and this would have still been my hypotenuse. But it is all according to the reference angle, that theta value, okay, and where it's listed. Sometimes it's going to say with the vertical, sometimes it's going to say with the horizontal. It'll just depend on where it says that is being placed or measured. Alright, so that's going to be our basic right triangle and just working on our side. So then if we talk about Sohcahtoa, and we have our reference angle here, then our opposite is our B, and our adjacent is our A, and our hypotenuse is our C. So if we want to talk about sine theta will be the opposite over hypotenuse. So if I wanted to make an expression for that, I would find B divided by C. Then, if I wanted to do the cosine theta, that would be my adjacent over my hypotenuse. So that's my c from above. And that would be A over C. So if I had values there, they would actually be substituted and I would have those. And then for tangent is the toa, so it's the opposite over adjacent. So I will put my B over my A. Again, those all have to be in the same units, so that there won't be any units when you have sine theta, cosine of theta, and tangent of theta. Alright? If they give you the theta, then you'll just type in sine and that theta button when you're actually doing your calculations in your calculator. The other thing is if you're missing one of those sides, but you have any two, you can use the Pythagorean Theorem, which is also underneath the right triangle section of our formula chart. And so it will be our c squared equals a squared plus b squared, and that's exactly how it's written. And they give you an example very much like this on your formula chart. The a's and b's are in a little bit different spot, but otherwise it's all the same. So if I have an angle here of 55 degrees, and I have a hypotenuse of 32 meters, then I want to find A and B. Well, one way would be to say that that's my hypotenuse, so A would be my adjacent side, and B would be my opposite side. So I could go ahead and start off with sine, and sine theta equals opposite over hypotenuse. So my sine of 55 degrees would equal my B over my 32 meters when I plug everything in. Now on my calculator, I would type that literally as it's shown, sine, and in the parentheses I type 55, and then I'd close my parentheses, and then I'd multiply that by 32. That would then give me my B by itself, because B would then be sine 55 degrees multiplied by 32 meters. So that would end up with 26.21 meters as my B side. Okay. Then there's two different ways that I could find A. I could find A by using cosine theta equals adjacent over hypotenuse, or I could use my A squared plus B squared equals C squared. And that would just be me solving for A and plugging in what I know B and C are. Again, this would also be just solving for A, cross multiplying So sine of theta multiplied by my hypotenuse would give me my adjacent side. Okay, so that would be one way to do both of those, and I'm going to click through this slide which will show you some answers that The next one would be the same sort of thing, but I want to find my angle this time. First of all, I have two sides, so I could do a squared plus b squared equals c squared. So in order to find c, I'd have to square root my 11 kilometers. 11 kilometers, and here's a game, huh? 11 kilometers squared plus 11 kilometers squared, taking the square root, would tell me that r's value was 11 squared plus 11 squared, square rooted is that would be 15.56 kilometers. Now if I want to find the angle itself, I can do tangent theta equals opposite over adjacent. So when I find the theta value, really what I'm doing is I'm dividing by the trig function. So that's going to be my inverse tangent of my opposite over adjacent. So I'm going to take my inverse tangent of 11 kilometers divided by 11 kilometers, which is going to be the inverse tangent in your calculator of 1, which is going to give you a theta of 45 degrees. Now, a lot of y'all might have realized that that was 45-degree angle because you have an isosceles or an isosceles triangle, but this was actually using the trig to figure it out, so I wanted to make sure I went back over that. That's really it. We're going to work on these things Wednesday. We'll work on some trig in class and go from there. So, hope you enjoyed it. It was short and sweet. Told you it would be. Thanks.